Hey everyone, we are going to look at section 1.6, which is about graphical transformations of functions. There we go. Okay, and so what we're going to look at is how graphs can be transformed, shifted, flipped, stretched, compressed in different ways. So the first thing, y equals x squared, we know what that looks like, right? It's an x squared function, looks like that. And if I do y equals x minus 3 squared, well, let's see what happens. 1, 2, 3. When I plug in 3, it's going to give me 0, the same thing this did at 0. And when I put in, I don't know, 1, let's see, no, when I put in 4, 4 minus 3 is 1, it's going to give me the same thing that happened at 1. So what this does is it creates a shifted function that's identical, just shifted horizontally in the positive direction. And likewise, if we do, let's get a little darker color so you can see it, y equals x plus 3. So when I put in 0 for x, it's going to give me what we did for 3. If I put in negative 3, it's going to give me what we did for 0. So at negative 3, I'm going to have 0 here. And it's going to look like this. It's going to be shifted 3 units in the negative direction. Okay? So when it's just x squared, the vertex is centered at the origin. When it's x minus 3, when I put a value of 0, it really feels like it's negative 3. So 0 came up here where we would be at negative 3. So look, it was shifted by 3 units. And the thing that's confusing about these is what direction they shift. So this one was a shift of negative 3, and this guy was a shift of positive 3. Hey, look at that. It's opposite from the sign, and it's opposite from the sign, and that's always going to be true. When you have y equals f of x minus c, that's going to cause a horizontal shift of plus c. There we go. In the positive direction, opposite from the sign. And we have y equals f of x plus c. That's going to cause, let's put 2 little lines so we differentiate. There we go. A horizontal translation, a horizontal shift of negative c. So it's going to be in the negative direction. The cat's trying to climb up into the ceiling joists of the basement here. Okay, so here's one of our rules for translations of graphs. This is how we do a horizontal shift to the positive or negative direction. Okay, we'll do a new one. Now, if instead, let's go back to our function y equals x squared, and I do, and so let's draw it on like this, y equals x squared. When I do y equals minus x squared, so let's see, here when I used x squared, I put my number in for x squared is going to spit out the y coordinate. So when I had a 1, I got a 1. When I got a 2, I got a 4. But what'll happen here? When I put in a 1 for x, what is this going to give me? 1 squared is 1 times a negative 1. I'm going to get a negative 1. There we go. 2 squared, 4 times a negative 4. So what this does is it flips it over. Okay? When y equals, minus f of x, this is reflection about the x-axis, or it's a vertical reflection. You take the function and you just flip it around, okay? But now let's look at the other reflection. Let's change colors so we're not confused. Boop. Okay, so if we have y equals, let's do our function as y equals x minus 2 squared. That's a beautiful 2. So that looks like 1, 2. So we're here, right? Positive 2 shift. And now I put in y equals a minus x. Don't really need the parentheses, but I want you to see it so you understand it. So y equals minus x. I should have done that in red or something. No, we'll use a different color. I'll go down here for dark or majestic purple. So this will be the purple one. So what that's going to do is I'm going to take my x value. When I put in 2, well, it's going to think I'm putting in negative 2, right? When I put in 0, well, 0 is a really bad example. But when I put in a negative there, it's going to think I'm really using a negative value. And it's going to make it feel like I did a reflection about the y-axis. So I did a reflection this way. Okay? So let's think about it here. Let's say here in the first one, I put in 3. Okay? So in the green, y equals 3 minus 2 squared. So that 3 minus 2 is 1 squared, equals 1, and let's do another point. Y equals 4 minus 2 squared. 4 minus 2 is 2. 2 squared is 4. Okay, now let's go to, so let's mark those. So 3 would be right here. 4 would be up here. Now let's go to Purple Town. And let's use this other function. Y equals minus 3 minus 2 squared. Well, that's going to be minus 5 squared. That's going to be 5 squared is, holy crap, that's 25. So, oops. So this is going to be minus 5 squared, which is the square gets canceled, 25. So it thinks we plugged in a minus 5, and on the green curve, 1, 2, 3, 4, 5, it's going to be way up here somewhere, right? So when I put in negative 3, it thinks that it's way off from where it was at. And oh, wait, let me go back to sharing. And when I use this value of x equals 3, the function thinks I was over here at negative 3, which is a big number, or maybe, yeah, it thinks it's a really big number. It ends up, we used 3, which was right here. It's going to give me a number way up here because it thinks it's on a different number. It thinks maybe it was on 5 squared or negative 5 squared. Those are both the same in this function. So it thinks it's on another place on the x-axis, even though we're at the point 3. And what that has the effect of doing, again, is, whoops, flipping the function around, not shifting. It's a flip. So if you had a function like this and you were like here and you did the minus x, then you would end up like this. It would be a reflection, not a shift. A reflection, not a shift. So if I have y equals f of minus x, then that means a reflection about the y-axis. can't spell. Okay, so let's summarize these things now. So we have y equals f of x minus c, and that is plus c horizontal shift or horizontal translation, same thing. Y equals f of x plus c. That's a minus c horizontal shift or horizontal translation. Y equals minus f of x. That was a reflection about the x-axis. Oops. And y equals f of minus x. Reflection about the y-axis. So these are 4 of our rules. Those are probably the most common ones, but not completely, because of course, we're going to add some more. So you may want to pause this and write it in your notes somewhere. Okay. Now, let's go to the next kinds. Now, we didn't talk about a shift in y, did we? Did we? We did not. So if I have y equals x minus 3 cubed plus 4, so let's see. As I said before, our original function is this. And I know what that looks like. It looks like that. But now let's do the new one in red. So this is going to be a horizontal shift of 3. And again, this thing gives me the y coordinate. So now this will give me the y coordinate as well. But whatever y coordinate I get, I'm going to add 4 to it. So if I put in x equals 3, I would normally get 0, except, oops, I got to add 4. So it shifts this point 3 units positive because it's opposite from the sign. But here's where the pattern breaks down. It's 4 units in the same direction as the sign, because the 4 is not grouped up with y, so it would be opposite from the sign. If it's grouped up with its variable, it's opposite from the sign. If it's not grouped up with its variable, it's the same direction as the sign. So this is same direction, up plus 4. So now my function is here, so it looks like something like that. So 2 shifts, horizontal shift because of that, vertical shift because of that. So a general rule would be y equals f of x minus c plus, what do they use here? Do they give me a variable name? No, and I'm going to make it up, k. So this would be horizontal shift of plus c. Horizontal tells me it's on the x-axis, so I don't have to say that. And this one would give me a plus k vertical shift. Okay, if it was minus k, if it was minus 6, then that point would be 6 units down here. Okay? This is what gives us the translations. Let me pause for a minute. Okay, we're continuing. Where's my, there it is. Okay, so let's go do a new one, because now we have horizontal shifts, we got vertical shifts, we got reflections about the x-axis, and we got, oops, reflection starts with F. reflections about the y-axis. Right? 1, 2, 3, 4, 5, 6 kinds of graphical transformations. What's better than 6? 7, of course. Let's get some more. Person with the most shifts wins. Everybody knows that. Okay, so now this is shrinks and stretches. And I'll tell you, some of this really doesn't make any sense. And so you got to keep the rule in mind. You're going to write this on a nice, clear little piece of paper, a cheat sheet for when you take a quiz on this. And all you got to do is look at your cheat sheet, and it'll be easy peasy. Okay? I am not going to make a cheat sheet for you, but if you come to me during office hours, I'm happy to look at your cheat sheet and see if it's complete. Now, if you have a function, y equals f of x over c, okay? Now, you're going to say, why do I got to do f equals x over c? Because what if I have something that f of 2x? Okay, obviously that's going to make it bigger, so don't mess with me. Well, you got to remember 2x here, if we put it in this form, and this is something that students struggle with a lot, and so you got to get your head straight around this. If I have something like 3 over 1/7, and how much do we enjoy a fraction in the denominator? Yeah, like not at all, right? So the way you get rid of a fraction in the denominator is you multiply by the reciprocal. I'll multiply by 7 over 1, and I'll do the numerator 7 over 1. Cancel, 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 cancel. So we end up with 3 times 7 over 1, or 21. So when you have a fraction in the denominator, I don't care what it is, a over b divided by c, this is going to be the same as, I'm not going to do an arrow, I'm going to do an equal sign because it's equal. Flip that and just stick it in the numerator, times c over b. When you have a fraction in the denominator, you flip it and stick it into the numerator. Okay? So 2x here, well, that's kind of like I had x over 1/2, and I flipped it and stuck it into the numerator. And that's exactly what this is. So when you see something like f equals 2x, you got to put this in this form so that you'll get it right and you won't get it backwards. So I'd write this as f of x over 1/2. And you'll see why that's important when we talk about what these rules mean. Okay? So now here's the rule. When we have this, when we have x being divided by some kind of number, or multiplied, which really means divided by a fraction. Very important. If c is greater than 1, then this is a horizontal stretch by a factor of c. So if I had something like y equals x minus 2 squared, instead I had y equals x divided by 2 minus 2 squared. If this is f of x, if that is f of x minus c, then this is f of x over 2 minus c. C in the denominator, c in the denominator. If c is bigger than 1, this is a horizontal stretch. So this function here, y equals x minus 2 squared. I go 1, 2, and here would be my normal parabola sticking up. But the minus 2 means I'm going to stretch it by a factor of 2. So instead of being like this, it's going to get stretched way out by a factor of 2. Okay? So if I go to 3 minus 2 is 1. Well, really, it's going to end up one more. It's going to end up 2 times away. Okay? It's going to have the effect of doing this, and we'll do it on a graphical calculator thing online, and you'll see. Okay? In fact, I'll do that during office hours if you're interested in seeing it. But when C is greater than 1, it is a horizontal stretch with a factor of C. Okay? Turn that off. Okay, and if C is less than 1, oops, that is actually the same thing. There we go. If C is less than 1, then that means that it's a horizontal shrink or a compression. Take the function, I'm going to squeeze it and make it skinnier by a factor of C. So the important words are horizontal stretch or horizontal shrink, or you could say horizontal compression. That'd be equivalent. You can do either one. Okay? Oh, awesome. We got 2 more rules. So we got horizontal stretch, horizontal shrink. We're going to get 2 more to make it an even, I don't even know what number we're up to. Okay, now vertical, those last ones are horizontal. Vertical shrink or stretch. If f of x equals c times f of x, if c is greater than 1, then that's going to mean a vertical stretch. And if c is less than 1, then it's going to be, that is not good spelling. There we go. Vertical shrink. Okay, so if I have a function y equals x squared, and I want to figure out what is y equals 2x squared, well, here's y equals x squared. Y equals 2x squared. I'm going to take this point and I'm going to move it up 2 times higher. I'll take this point and I'll move it up 2 times higher. So it's going to become a thing like this. Now, what I don't like about this is that vertical stretch kind of looks like a horizontal shrink, right? And it does. And it's hard to tell by looking at the graph. We're never going to look at the graph and say what happened probably, unless it's just easy shifts, horizontal and vertical shifts, or reflections are pretty easy to tell. These horizontal and vertical stretches and shrinks, it's really hard to tell by looking at the graph. We'd have to look at the equation. Now let's go to, come on, there we go. Y equals x squared over 2. Remember I said this gives me the y coordinate? Well, it's going to take the y coordinate and double it. That's why it gets stretched up. And this is going to take the y coordinate and flatten it. So this is going to be a flatter one where it's been compressed by a factor of 2. Okay? So let's see if we can summarize all of our rules. Let's see if I can do them from memory with my notes right next to me that I can look at, but you can't tell I'm looking at them. Okay, so graphical transformations. So we have y equals f of x minus c. So that's a plus c horizontal shift. Y equals f of x plus c. That's a minus c horizontal shift. Y equals f of x plus k. Oops. I guess we could use c. Anyways, that's a plus k vertical shift. Y equals f of x minus k. That's a minus k vertical shift. Okay, now we get a reflection action. Y equals minus f of x. That's a reflection about x axis. Y equals f of minus x. That's a reflection about the origin, about the y-axis. So it's flipped horizontally. Okay. Oh, and what would f of, oops, here's a fun question, minus f of minus x. So that would be both a reflection about the x. How would that even look? Let's use this. So that would be reflection about the origin, because it would be first the inside one would give me a reflection about the y-axis, and then the outside one would give me a reflection about the x-axis. So we got to do a bit of a flippity flop. We get back the same thing again. So it would be there. So that's a bad example. It would flip the red one this way and you end up right on top of the blue one. So you'd end up with what you started with. But anyways, that's a bad example. But it would be a reflection about the origin. Okay, now we got, still doing it by memory here, of course, the stretches and shrinks. Y equals f of x over c. If c is greater than 1, then this is a horizontal stretch. If c is less than 1, then it's a horizontal shrink. And lastly, y equals c times f of x. If c is greater than 1, vertical stretch. And I got room, c less than 1, vertical shrink. And I think that's it. Did I get them all? Yeah. So these are all the rules for all the transformations. It's really important you look at some of the example problems in the textbook. I'm going to be doing example problems on these. We got time. Let's do one. So yeah, we'll do this one. This is number 44 in the textbook. Y equals minus 3 square root of x plus 1. Okay, so we want to know what kind of transformations are here. And my base function, when I take all the transformations out, is y equals square root of x. This is my base function. You see how I get that? I look at what's inside the square root function and I take the things that are translations. So I have 1, 2, 3 things, right? So this one, I work on the inside out. So this is a horizontal shift of -1. So a shift in the left direction. And what's this? That 3 is in front of the function. Which one is that? So that's like y equals 3f of x. And so that one is going to be a vertical stretch of 3. The vertical stretch factor is 3. And then lastly, the minus sign. What did that one do? Let me look here and make sure I get it right. So that's going to give me a reflection about the x-axis. So these are the kind of problems that we do, that we need to look at it and figure out what kind of shift is at play there. Well, that one's too easy. That one's really hard. So how about this? Y equals 1/5 x to the third. Well, that looks like x over 5 cubed, and my base function is y equals x cubed, and I take all the translations away. So this looks like x over c, and what was the rule? When c is greater than 1, it's a horizontal shift. So this is a horizontal shift of 5. See what my cat's eating. She found a ping pong ball, so she's having a little ping pong ball party. Horizontal shift of, I guess we want to say shift factor, because it's not a horizontal shift. That is completely wrong. Why didn't somebody stop me? Horizontal stretch. There we go. Of 5. So it's going to be 5 times wider because of that 1/5. Okay, these are the kind of problems we're going to do. You have to be able to identify these on the function. And so you want to make sure you look at the homework and come to office hours if you have questions. Okay. So I guess that's it. Any questions? Well, nobody asked a question. Okay, I guess we're done. See you later. Bye.